Hi, today I'm going to give you a brief overview of the history of cryptography. There are two types of cryptography. The first is symmetric, where both the sender and the receiver use the same key to encrypt and decrypt the message. The second type is asymmetric, where there's a public key that the sender can use to send an encrypted message to the receiver, but only the receiver can decrypt the message using a private key that only he or she knows. In 1900 BC, the tomb of Khnumhotep II was drawn with some strange or unusual hieroglyphs. Although this was likely not done to portray a secret message, it is the first time that such techniques were used, and thus begins the history of cryptography. The first known encryption happened in 1500 BC in Mesopotamia, when a craftsman disguised a pottery glaze which he believed to be commercially valuable by omitting letters and changing the spellings of some common words. Around 500 to 600 BC, we saw the introduction of two new types of ciphers. The first was the Hebrew Atbash cipher, which was a substitution cipher, meaning that each letter in the plain text would be replaced in its ciphertext. Their method was to use a reversed alphabet. As an example, if you used our alphabet, that would mean A would be replaced with Z, B would be replaced with Y, and so on. The second is the Greek skytail, which is a transposition cipher, meaning that each of the letters in the message is just rearranged in the ciphertext. The Greeks achieved this by wrapping a very long strip of leather around a skytail, which is the instrument you see in the picture. They would write their message across the skytail, so that when the leather was unwrapped from the instrument, it would just be a long string of letters. You can see in this next picture what a message, "Send help," would look like wrapped around the skytail and then unwrapped. The next major breakthrough in cryptography was the Julian substitution cipher, which Julius Caesar used to send secret messages to his troops. The general idea is that the cipher alphabet would be in the same order as the normal alphabet, just starting with a different letter. For example, if you wanted to do an E shift, the alphabet would start with E and then wrap around to A once it reaches Z, as you can see on the picture on the screen. After the Julian substitution cipher, there were no major breakthroughs in encryption for over 1,000 years, but there were some breakthroughs in cryptanalysis, or breaking codes. The 800s to 1400s AD were called the Arab Age in cryptography. Two major contributors were the mathematician Al-Kindi and the Subh al-Shah Encyclopedia. Al-Kindi wrote the first text on cryptanalysis and breaking codes. Both included parts about frequency analysis, determining which letters occurred most frequently in Arabic, as well as which letters cannot occur together. The encyclopedia also had the first mention of using multiple letters for one substitution. We'll see more of this soon. The next major breakthrough was the Vignere cipher in 1500 AD. This cipher used a shifting substitution, meaning that it would shift through a keyword. For example, if our keyword was luck, we would use an L shift, an O shift, a C shift, and a K shift. Now say the message that we want to send is crypt. To find the ciphertext for the first letter, the C, we would take the third position from the L shift. For the R, we would take the 18th position from the O shift, and so on, until we wrap around and take the 20th position again from the L shift to find the ciphertext for T. In the early 1900s, the Hebron rotor machine was invented. This machine was a typewriter with a rotor connected to it, which changed the alphabet every time a key was pressed, essentially making it a mechanical Vignere cipher. It had a significant advantage in that it did not necessitate a key, just that the receiver had a similar machine with the exact same rotor that they could use to decrypt the message. The Hebron rotor machine was very easily cracked and was not very commercially successful, but it was a precursor to the very successful Enigma machines that the Germans used in World War II. The Enigma machine was a much more complex version of the Hebron machine. It added up to 5 rotors with different wiring to change the substitution alphabet after each key press. There were 5 elements that added to its complexity: the order of the rotors, the initial position of the rotors, the position of the ring relative to the wiring, the connections of the plugs in the plug board, and the wiring of the reflector, creating up to 158 quintillion different settings. The Enigma codes were cracked by reverse engineering the original machines and using a codebook found in a German vessel. Lastly, in 1975, the first asymmetric cipher was invented. Called the Diffie-Hellman key exchange, this system is protected by the current inability of computers to factor very large numbers. The sender sends messages using an encryption exponent coupled with a number that is the product of 2 large primes selected by the receiver. The receiver uses the 2 prime numbers to decrypt the message. Because no one but the receiver knows the factorization of the large number, and the factorization of sufficiently large numbers is currently impossible, the exchange is secure. Thank you for watching, and I hope you enjoyed it.